Hi, my name is Cesar Ago, and I would like to describe my poster. So the title of my poster is Renyi entropies in the going to zero limit entanglement temperatures and holography. This is based on published work and ongoing work with Horacio Cassini and Pedro Martinez. So the main motivation of the work is to understand the physics of states reduced onto arbitrary spatial subregions in quantum field theories. It turns out that a particular set of observables that one can associate it to such states are given by the so-called Renyi entropies, which together characterizes the eigenvalue distribution of the reduced state. On the other hand, such states one can causally complete or have a complete description of such states by using the time evolution generated by the modular Hamiltonian, which is simply the logarithm of the reduced state. So essentially, the state is completely determined or characterized by the modular Hamiltonian. An interesting way to probe the local structure of such modular Hamiltonian turns out to be the following. So one can consider the relative entropy between the ground state and an excited state, which is built out of this by acting with the highly energetic and localized unitary operator. It turns out that such relative entropy scales with the energy when the energy is very large, and the proportionality coefficient between relative entropy and energy is a quantity that has the units of temperature and is what is known as the entanglement temperature. Roughly speaking, that notion of temperature characterizes the local structure of the modular Hamiltonian. On the other hand, the Renyi entropies can be related to the von Neumann entropies of some excited states. Those excited states are just the reduced state raised to the power n, and those states additionally can be interpreted just as ordinary thermal states, but with respect to the notion of energy provided by the modular Hamiltonian, and with temperature, which is given precisely by the parameter n, which is the Renyi parameter. Therefore, from this perspective, one would expect that the limit that we are interested in, the limit in which the Renyi parameter goes to zero, is actually essentially just a high modular temperature regime of that system. And therefore, one would expect that the high energy structure of the state will suffice to provide an effective description of such states. And it turns out this to be the case. So in particular, in free theorists, one finds actually that the state brought to the end is described in terms of an infinite set of conserved currents, which in turn are completely determined from the entanglement temperatures, which are, as I mentioned before, basically codifying the local structure of the modular Hamiltonian. On the other hand, in the context of holographic theories, we conjecture that the description or the effective description is actually the one of a perfect fluid. So using this philosophy, together with the proposal of Dong for the geometry dual to the Renyi entropies, then it allows us to construct an ansatz for the holographic dual to the state rho to the end, which allows us to compute in particular the Renyi entropies in an arbitrary region in 2 dimensions and check with some known results. So basically this is one of our results, and this is the content of the poster. Thanks.